Good morning. So today we will be factoring special cases. What I wanted to start with is actually foiling special cases to kind of help get your mind back into factoring them. So the first one that we're starting with is x plus 3 squared. Now remember, when we are squaring these, we are not taking the 2 to both, rather expanding. So we get x plus 3 times x plus 3. And then we are left with x squared plus 3x plus 3x plus 9, leaving us with x squared plus 6x plus 9. This is going to be called a perfect square trinomial because that is a perfect square, 9, of 3. So let's look at the next one, x minus 4 squared. So we expanded out x minus 4 times x minus 4. And we get x squared minus 4x minus 4x, and then negative 4 times negative 4 is plus 16, leaving us with x squared minus 8x plus 16. So like I said, 16 is a perfect square of 4. These are both perfect square trinomials. So you might want to get the list out of perfect squares. We got 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 for 1 through 10. You might want to write them somewhere or help you out today. So the last one we have is similar to these, but you have a positive and a negative. So when you FOIL this out, you're left with x squared minus 3x plus 3x minus 9. Now, when you have a negative and a positive, they come out like this. Negative 3 plus 3 cancels out, and you're left with x squared minus 9, which is called a difference of squares. Because difference means subtraction. 9 is a perfect square, and actually in all of these cases, 1 is a perfect square. So you're going to use these as we go through today. Our first 2 examples are going to go with A and B, and then the one on the back will go with C. Okay, so let's start with the first one. So this looks familiar to what you did last week. We're factoring. It looks like A, B, C. So there's going to be 2 ways to do this. Old way, which is what we did last week, and pattern. You are more than welcome to do the old way the whole time through. However, if you see a pattern, like everything in math, it's going to make your life a little bit easier. So this will become 1, negative 12, and 36. We'll solve this one the old way and this one with the pattern, and hopefully you get the gist. So we're trying to figure out which 2 numbers multiply to 36 add to negative 12. So you're finding 2 factors. It winds up being negative 6. And negative 6 give you positive 36 and negative 12. Put them under 1x. And you'll notice they're the same. If this is a perfect square trinomial, these will always be the same. So if they're not the same, not a perfect square trinomial, or you chose 2 of the wrong factors. So this can be written one of 2 ways. Traditionally, this is how you're used to writing it, x minus 6 times x minus 6. But you might start seeing it written like this. I am good with either way. They both mean the same thing to me. So if you notice, 36, perfect square is 6. 1, 1. So now we're going to take that sort of idea and use the pattern. 1 is a perfect square. 81 is a perfect square. We don't necessarily care about either of the middle terms right now. So we'll drop down what the perfect square is. So perfect square of 1 is 1. Perfect square of 81 is 9. X minus 9 squared. You'll notice it's minus because up here, when you have a minus to begin with, your binomial should have a minus. If you have a plus to begin with, your binomial should have a plus. Both of these had the first b was negative, so that becomes negative. And that's all you got to do. Where the pattern comes into play is when the numbers are a little bit bigger, like down here. So let's do the old way for this one. So 4, 20, 25. And now we're working with 100, which is a little bit bigger of a number, especially when it comes to less common big numbers. So you're saying, okay, what two numbers multiply to give me 100, add to give me 20? Hopefully 10 and 10 popped in your brain. Remember, now you have 4x, not just x. And you've got to reduce, but really you only have to reduce 1. So you get 5 over 2x. So your final answer is 2x plus 5 squared. Now, where the pattern comes into play the most is on this next one. Because like I said, when you get bigger numbers, you want to be able to do a little bit easier of math. So if we did 9, 42, and 49, you'd be left with 441. Not really a number I would like to work with if I could help it. So take your perfect squares. 9's a perfect square. 49's a perfect square. So now I'm left with 3x and 7. That's a plus sign. So it becomes 3x plus 7 squared. That's it. So keep in mind, ax squared plus bx plus c will result in x plus a number squared, and ax squared minus bx plus c gives you x minus a number squared. All right, so like I said, that dealt with examples or A and B. Now we're going to look at the difference of squares. So recall, a negative and a positive got rid of the two middle squares. So now we're going to be starting with this and trying to get back to there. So when we factor the difference of squares, a couple things have to happen. First, only have two terms. So you can only have two terms here. You'll notice that B is missing. I have AX, I have C. The second thing that has to happen for this to work is A and C have to be perfect squares. If one is a perfect square and one is not, it does not work. Remember, difference of squares. They both have to be squares. Something I use to help myself remember this is if I only have two terms, that means, two terms equals two binomials. That means that when I have two terms, my final answer is going to have two binomials, not just one binomial squared. And then the last thing is one positive, one minus. So 1 plus, 1 minus whenever we do these. So let's start factoring simple. Unfortunately, you have to use the pattern for this because you'll notice there's no bx, so you can't ABC something that doesn't have a b. So use your squares. Perfect square of 1 is 1. Perfect square of 9 is 3. Remember, I need to have one positive, one negative. X plus 3, x minus 3. That's it. Because when you factor that back out, x squared plus 3 minus 9, middle terms cancel. Good to go. This next one, again, 1w because 1's your perfect square. Perfect square of 100 is 10. W minus 10. W plus 10. So it doesn't matter if the subtraction sign's first and the addition. Either way, I'm good with. Let's go into a little bit higher of numbers. So 16x squared minus 81. Perfect square of 16 is 4. Perfect square of 81 is 9. We'll add the x in there. So this step right here I think is helpful because it really shows you exactly what you get for that binomial. 4x minus 9. 4x plus 9. And then the last one here, perfect square of 25 is 5. D. Perfect square of 64 is 8. 5d plus 8. 5d minus 8. That's it. I will be teaching this lesson at 8:30 and 11:30, and your homework is 1 through 10 on Google Classroom. Good luck.